Hi everybody, this is Mr. West, and today we are doing another Kuta worksheet tutorial, this time on systems of equations word problems. Okay, everyone's least favorite, word problems plus systems of equations. Your worst nightmare. Let's go ahead and make this a little less harmful, a little bit more bearable for you. Number one, find the value of two numbers if their sum is 12 and their difference is 4. Well, you already know you're dealing with the worksheet that says systems of equations, so you need one and two equations. You're going to have two equations that you come up with. Now, the whole point of having two equations is because there's two variables, and you can't solve two variables with only one equation. So we know we're going to be using an x and a y. So this x has to be some value that we're going to determine, and then some y value that we're also going to determine. So here we go. We have two numbers here, and their sum is 12. So x is going to be a number, and y is going to be a number. And it says their difference is 4. So we know that both of these are numbers. Now, if you want, you can say, all right, I want the x specifically to be the bigger number. It's not required that you do that, but it might make it a little bit more sense in this tutorial. So we say that's the small number. Okay, now the first part is easy. Their sum is 12. So two numbers, they're unknown. We don't know what they are. So we say x plus y equals 12. The second thing, okay, is much more complicated. Okay, so this says two numbers added together equals 12. The second thing is a little bit more complicated, but not too bad. Their difference is 4. Okay, so what does that mean? Difference means subtraction, so we're going to be subtracting, and it's equal to 4. Now, if it's equal to 4 and not negative 4, that means the bigger number is doing the subtracting. So we can say x minus y, the smaller number, equals 4. So we have x minus y equals 4. All right, so we have x minus y equals 4, x plus y equals 12, and now we can solve this system of equation. So let me go ahead and highlight one of the ones that we should do. Now what I'm going to do here is I'm going to solve for x and then substitute it into the other equation. So I'm going to do substitution just because it's pretty easily set up for it. And I'm going to add y to each side. Actually, elimination is probably easier, but I'll show substitution first. In the next problem, I'll do elimination. So I add y to both sides. I get x equals 4 plus y. And then I'm going to substitute this value of x in for x. Now I'm going to rewrite this equation with 4 plus y. Okay, that's my new value there. Plus y equals 12. Now I solve for y. So I have 4 has no other like term, so we have 4, and then y has another like term, 2y equals 12. We're going to subtract 4, we get 2y equals 8, so y equals 4. And once we have one of these numbers, it's very easy to find the second one. Okay, so we have y equals 4, and now we can just plug it into either equation. In this case, I'm going to choose the top one. Looks a little bit easier. So I say x plus 4 equals 12. So we subtract 4 and we get x equals 8. So now we know that one of our numbers is 8. Remember, always go back to what it's asking. One of our numbers is 8 and the other number is 4. Okay? So now we're going to move on to number 2. Very similar problem. The difference of two numbers is 3. Their sum is 13. Find the numbers. Okay? I'm going to be a little bit less specific in this one. So we know we have two numbers, x and y. And we know their difference is 3. So we're going to say x minus y equals 3. That means x is going to be our bigger number. Their sum is 13. X plus y equals 13. This one's set up perfectly for elimination because the y's have opposite coefficients. We can just add and we get 2x equals 16 because the y's eliminate. We divide by 2, x equals 8. And now I know what you're thinking. You're thinking, why didn't I do elimination in the first one? That's a good question. So once I get x equals 8, I'm going to go ahead and plug it back in to our equation. It doesn't matter which one. I'm going to pick this one, the second one. I did a little psych out right there. So we have 8 plus y equals 13. I subtract 8 from both sides, and I get y equals 5. So now I have my two numbers. The two numbers are 8 and 5. 8 minus 5 is 3, as it suggests there. And then I have 8 plus 5 equals 13. So then it's I have both those equations configured. I'm good to go. Okay, a little bit tougher now, increasing in difficulty as we go along here. Flying to Kampala with a tailwind of a plane averaged 158 kilometers an hour. Okay, so let me kind of draw this out graphically So we have an airplane here. Very nice airplane if I say so myself. Okay, and it's flying with the wind. Okay, so the wind is going this way. And the plane is going that way. Okay, and it averaged 158 kilometers an hour. The return trip, okay, so now the plane's going the other way. Okay, and the plane somehow changed shape a little bit. And it's going against the wind now. So obviously it's going to go slower. It's like when you go to the airport and you find those little people mover things, those little walking sidewalks. If you're walking with it, man, you haul and you don't even have to work hard for it. But if you're like one of those kids that tries to go the opposite way, you're going to go very slow because you're fighting the current. You're fighting the force that's naturally propelling you in the other direction, okay? So how do we put this into equation form? How do we say, okay, with the wind we go faster, without the wind, or against the wind, we go slower? One way to do that would be to say we need two variables. We need P to be the plane, okay? So P is going to equal our plane, and we're going to have W equals our wind. Okay, so now, if the wind is going with us, what do? We have the speed of the wind, the speed of the plane. We are going to add the two speeds together. So we add in this case. And if you're fighting it, you subtract. Okay, so you add the speed if it's going with you. You subtract it if you're going against it. So now we have our two equations. It's going to be P plus the wind. It's helping us. Equals 158. And then we have P, the speed of the plane minus the wind equals 112. We do the P minus W and not W minus P because W minus P would mean the wind is going way faster in our plane, and hopefully that's not the case. That would be very, very dangerous. So we're going to go ahead, and what we're going to do here is these equations are set up perfectly for systems of equations by elimination. So we're going to eliminate here. I'm going to add because we have opposite W's, and we're going to eliminate our W's, and we have 2P equals, what is that, 260? No, 270? I think it's 270. Let's double check 158 plus 112. Okay, 270. And now we're divided by 2, and we get P equals 135. What does this mean? Well, we already established our variable, that P equals the plane. That's the plane speed. So this is 135 kilometers an hour. And that's actually really slow for a real plane, but again, this is just a word problem. Okay, so we have P equals 135. Now we need to find the speed of the wind. Well, how do we do that? We can just input this into our original equation and say 135 plus W equals 158. So then we do the old-fashioned subtraction, and we get that the speed of the wind is 23 kilometers per hour, km per hour. Okay. So then we got that one done. All right, we'll see how long. I think I'm going to finish this first page in video part 1, and then I'm going to do the second page in part 2, just in case you're checking your watch. The school that Stefan goes to is selling, this one's pretty easy, is selling tickets to a choral performance on the first day of ticket sales. The school sold 3 senior tickets. Okay, so this equals senior, and then we have child tickets. Okay, so child tickets and senior tickets. So 3 seniors plus 1 child equals 38. That was this equation right here. 3 senior tickets, 1 child ticket. Okay, because you add the price of each ticket, but since we sold 3, we can just do 3 times the price of the senior ticket. So technically this is the price of the senior ticket and the price of the child ticket. The school took $52 on the second day by selling 3 senior tickets and 2 child tickets. So we have 3 senior tickets plus 2 child tickets equals 52. Okay, so how do we find our different prices here? That's what it's asking for. Well, it's not ready for elimination, but we could multiply the bottom equation by -1 and make everything here minus. So what we did here is we multiplied this equation by -1 and just made it all minus. Okay, so you make it all minus. And this is kind of a shortcut, so I can kind of skip writing it over again. I wouldn't suggest doing that unless you have experience watching some of the Wes Explains Best videos on system of equation by elimination. So just make sure to keep that in mind. So because we did that, they're opposites and we're ready to add. Some teacher will tell you subtract. That is also good, but I find that it complicates students, so I just teach the addition method. And then we have equals, and then we multiplied this by -52, and that's going to give us what, -14? -14. So C equals 14. Now, we have to find our other value, so we're going to plug this back in. Oh, yeah, that's correct. So the c equals 14. So we're going to plug this back into here for child, and we get 3s plus 14 equals 38. So we subtract 14 from both sides, and we get, what is that, 24? So we get, my pencil's acting up. So we get 24 equals 3s. So then we divide by 3, and we get a senior ticket costs $8. So a child ticket is $14, and a senior ticket is $8. And that's how you set this up. Make sure you set your variables from the start. You know you're going to need two equations, and then you go from there. The sum of digits, okay, this one's a really tough one. I'm going to save this one for last, and I'm going to skip to number 6. But if you want to see what number 5 is, go ahead and stick around. So a boat traveled 210 miles an hour downstream and back. The down trip took 10 hours. The up trip took 70 hours. What is the speed of the boat in still water? Very similar to, was that number 3 with the speed of the current helping our boat? Okay, so our boat was helped on the way down. Okay, we have a little propeller on it, so it can go against the current. But on the way up, it took 10 hours. Now, here's the deal. It gives us the time, but it doesn't tell us the speed. So what we have to do here is we have to calculate the speed. It goes 210 down and 210 miles back up. How do you calculate speed? Well, you do miles per hour. That is for the down trip with the current. So, okay, this is with the current. Again, with the current, you are adding. So if we're adding with the current, okay, this is our speed. We're going to say 210. Whoops, I have the wrong color. 210 divided by 10 hours. That gives us 70 miles per hour. That's hauling in a boat. I'm guessing these are just made to be easy and not to be realistic. So 70 miles an hour. Now, the exact opposite happens as you go upstream. So here we have the stream is going this way, and your boat is trying to go upstream, okay, making it difficult. In this case, we subtract because you're fighting the current, okay? So we go the same 210 miles, but in this case, we have miles per hour. This case, we go 210 in 70 hours. This ends up being 30 miles per hour. Now, we found the speed of the boat with the current and against the current, but not in still water. It's just asking how fast would the propeller move itself. Well, we need an equation for that. We need the speed of the boat. So speed, let's make this current. So we need the current speed. The current is the river, how fast it moves. And then we have the speed of the boat, which is of how fast the boat is moving. Okay, so 70 miles an hour it gets helped. So we have 7 plus c, the speed of the boat, s plus c equals 70 miles an hour. If you're fighting the current on the way up, it's s minus c equals 30 miles an hour. And here we have our system of equations ready to go. Setting up the system of equations is the hardest part to do, but the more you do it, the quicker you can see the pattern. So here we're going to add these two equations. We get 2s equals 100. So the speed of the boat in still water is 50 miles an hour. That's super fast. So we have 50 miles an hour. Now what we're going to do is we're going to plug this in to one of our equations to find the speed of the current. So we go here and we'll just plug it into the top one. Okay, so we say, oops, that's the wrong letter. I need to plug it in for S. So plug it into S, and so I get 50 plus C equals 70. Subtract 50, and I get C equals 20 miles per hour. Okay, on to the last problem, which is pretty tough. Okay, it requires kind of an understanding of two-digit numbers, which is pretty complicated. But let me go ahead and show you. So the sum of the digits of a certain two-digit number is 7. Okay, this is the first equation, pretty easy. So we have two digits, and they equal 7. So x is the first digit. Am I saying that right? Digit. All right, there we go. Got to enunciate a little bit more. Second digit. Okay, now, reversing its digits increases the number by 9. That is a lot in one statement. So if we're thinking here, for example, if we have the number 21 and we reverse its digits, it's 12 when we reverse the digits. Notice how the value here went down 9, okay? Well, this doesn't add up to 7, so even though it goes down by 9, it fulfills the second part. It doesn't fulfill the first equation, x plus y equals 7. 2 plus 1 equals 3, not 7. Okay, now how do we write this into equation, this phenomenon into equation? Well, it's very difficult, I'm going to be honest. It's pretty tough for a lot of people to recognize how to do that. What you have to recognize is the place value. So if you have the number 21, what does this mean? Well, it's just not you take the number 2 and you add 1, that's 3. Okay, so how do you get 21, the value of 21, from a 2-digit and a 1-digit? Well, what you do is you take the 2 and you multiply it by 10, and you add it to 1. Remember that this is the tens place. Okay, the first digit in a 2-digit number is the tens place, and the second digit is the ones place. Okay, so it keeps its value, but the first place gets multiplied by 10. Okay, so if x is our first digit, okay, then we'll multiply that by 10, x times 10, and then we add that to our second digit, y, plus y. Okay, and that represents the number before we reverse it. Now, after we reverse it, okay, so we move the 1 to the 2, where the 2 is, and the 2 to the 1 is. This is an example, okay? Don't think that I'm solving the problem here. This is an example to highlight how to figure this out. How does it change? Well, we have 1 times 10 plus 2, and that equals 12. So remember, we have to multiply the tens place by 10. So we have to do that for y, okay? So now we're going to do 10 times y plus x. Now, if they were equal, we would say, oh, okay, they're equal. But if we reverse the digit, like for example, if we reverse the digits for 55, it stays 55. The value doesn't change. But that's not what it's saying here. It's saying reversing its digits increases the number by 9. So how do we account for that? Well, if it increases it by 9, remember this is reversed right here. This is reversed. So it increases that number by 9. So if it's increased by 9, then we have to add 9 to the smaller number. This number is smaller, so we have to add 9 to it for it to be equal. This is the most complicated part right here. I would go back and rewatch this if you can, okay, just to understand this concept right here, that you have to add 9 to the smaller number to get the bigger number where you reverse the digits. Because remember, it increases the number by 9. That means you have to add 9 to the smaller number to get to the bigger number. So all in all, we would have the first digit number, or the first number, 10x, tens place, plus y, plus 9 equals 10y plus x. This is our second equation. So our first equation was over here, x plus y. That one was easy. This one is very difficult. Okay, so we can just get the x's and y's on both sides now, or on one side. So we're going to subtract 10x and 10y from both sides. 10x, oops, wrong spot, minus 10x minus y, and we get 9 equals 9y minus 9x. Now, because of all the 9s and everything, what I'm going to do is I'm just going to divide everything by 9, which you can do as long as you do it to both sides. And I get my second equation of 1 equals y minus x. I'm going to move that guy over here. 1 equals y minus x. Okay, see how it's the same thing? I just kind of flipped the sides. Because now what we're going to do, I'm going to rearrange this again, sorry. I'm going to put this negative x in the front, move this y over, and I'm going to add it because it's a positive y. Okay, I'm doing a lot of cool math concepts that you may not have seen before, but I'm hoping you can follow along and see that organization really impacts how well you do in a math problem. So now we're ready to add these. I was hoping for that line to be straight, but that is not the case clearly. Let me try that one more time. Nope, didn't really work. All right, pencil's acting up again. So we have 0 there, it eliminates, and we have 2y equals 8. Divide by 2, divide by 2, we have y equals 4. Now we can plug this back into our original, okay, and then we have x plus 4 equals 7, minus 4, x equals 3. So what are the two numbers? Well, the first number was 34, okay, the first digit, 3, second digit, 4, and then we reverse the digits, and we get 43, and it increases the number by 9. So there you have it. That was a long video, but word problems are really tough. Hope you enjoyed this video. Stick around for part 2. See you soon.